In today's Daily Dose of Math, we're looking at a type of question that students encounter when they're studying the Sec 3 algebraic modeling course. This course has a lot of emphasis on straight lines, the linear function. And this question presents the student with an equation for a straight line in y equals ax plus b form, and a graph of that line. The question is asking the student to try doing 4 different things that will change the line by changing the a and the b, the slope and the y-intercept of that line. And then answer what transformation happens. The students in my class are able to do the operations they're being asked to do and produce the graphs that they're asked to produce, but then they struggle with explaining what transformation happens. And this is because this is one of those times in math when you're being asked to use the concepts from one topic in math and apply them to a different topic. Transformations include reflection, translation, and rotation. And those are enough to answer all of these questions. When they ask what transformation happens, they want you to use the language that goes with those transformations. The language of reflection, translation, or rotation. In each case, when we do the change that they're asking in part 1, 2, 3, and 4, we are making changes to the straight line in terms of rotating it, or translating it, sliding it, or reflecting it. Now, as a review, a translation is a slide. A rotation can be called a twirl, and it rotates around a point, and the point of rotation right here is my hand. And then a reflection has to have a mirror line. So here I'm using the ruler as a mirror, and if this is the original image, the reflection is going to look something like that. So it looks like it has reflected across that mirror. When you answer the question, you want to give a little bit of information about how the transformation you're saying happened is happening. Let's get into the question and we'll see some examples. I'm going to erase the y equals ax plus b form because I need this space right here. But remember, a straight line equation when written in this form has a, the slope, and b, the y-intercept. For part 1, we were being asked to multiply a by -1. So y equals 2/3 x plus 5 will become y equals -2/3 x plus 5. So I'll graph that. I'm going to do a quick sloppy graph here. And I'll show my original line. It looks something like that. -2/3 x means the slope is -2/3. That means that the new line is going to be tilted downwards, because that's what happens when you have a negative slope. But the y-intercept has not changed. So here's the y-intercept. It's 5. It's still 5. So what I need to do is show a -2/3 slope line going through that same y-intercept. And it's going to look something like this. What has happened to the original line? It has rotated clockwise around the point 0, 5. So my answer for number 1 clockwise rotation around 0, 5, or if you wish, around the y-intercept. This is a complete answer to this question, what transformation happens, that is using the language of transformation. And it's not just a clockwise rotation. It's a clockwise rotation around that y-intercept. This is important because that's what will always happen. But in fact, this isn't the only correct answer to part 1, because I can see a rotation there, but if I wish, I can also see a reflection across this horizontal line, which would have to have the equation y equals 5, because that y-intercept is 5. So I could say, instead of clockwise rotation around the y-intercept, I could say reflection across the line y equals 5. And in fact, if we look at the y-axis as the mirror, we also have a reflection across the y-axis. I've come up with 3 different correct answers that use the language of transformation to answer what happens when you multiply a, the slope of this line, by -1. When you're asked this question, if they're talking in the language of transformation, they want the answer in the language of transformation. Now I'm going to erase this one, and we'll take a look at part 2 of the question. What happens when we multiply b by -1? So this time we're keeping our a at 2/3. And if we multiply by b by -1, we get y equals 2/3 x minus 5. When I draw that graph, -5 is down here. But the slope didn't change. So the line is going to have the same angle, the same slope. I may not have drawn that very well freehand. What happens is our resulting line after multiplying by b by -1 was a slide. The original line slid down from 5 to -5 on the y-axis. So the answer to 2, it's a vertical translation downwards. And again, there's another possible right answer, because I can see, since I know both lines go on forever in both directions, I could see that this line, besides translating downwards, I could see that it looks like it translated to the right. So if a student says horizontal translation to the right, that's also correct. I prefer the answer vertical translation downwards because it shows that the y-intercept has changed. And that's really what we did when we did part 2. Let's look at part 3. Add 6 to b. Okay, so we're adding 6 to the 5. We're not changing the slope again. We end up with y equals 2/3 x plus 11. To graph this, I'm going to have to change my graph a little bit. This marker is running out of ink, so I'm going to switch to this other one. There's my x-axis, there's my y-axis. If the original one goes through the y-axis at 5, it looks something like this. But now we're having another one with the same slope that goes through the y-axis at 11. It's going to be tilted the same way because of the slope being the same. So what is a way of answering the question what transformation applies? A vertical translation upwards. Or a horizontal translation to the left. This line, if I move it to the left, eventually will become this line. Again, I prefer this answer, vertical translation upwards, because it makes the student think about how the y-intercept has changed. And that's what we did. Let's quickly do the 4th example. Now this time we're changing both a and b by multiplying both of them by -1. So that means we're going to end up with y equals -2/3 x minus 5. The original look something like this. Negative 2/3 x means that the slope is going downwards instead of upwards. And minus 5 means that the y-intercept is here. That's an interesting one. We can see this as a rotation, and if we want to say it's a rotation, it's rotating around the 0. It's rotating around the x-intercept instead of the y-intercept. That's one way of saying what happened, and that would be a clockwise rotation. But we can also see it as being a reflection where the mirror is the x-axis. And that's a pretty easy answer. Answer to 4, the translation that happens is reflection across the x-axis. But again, I will accept the answer, clockwise rotation around the x-intercept. And it's interesting that we can say that as an answer when we haven't even found the x-intercept. We know that's where it's going to rotate around because that's the point where the line crosses that x-axis mirror. Interesting. So when you're asked in a straight lines course to modify the a and the b, the slope and the y-intercept, and then explain what transformation applies, this is the sort of answer they want. They want you to use the language of reflection, rotation, and translation to explain what happens to your line. That's today's Daily Dose of Math. Please like, subscribe, and share.